Pathology is a field integral to the diagnosis of disease, but there are inherently subjective elements within this field that create wide variation among pathologists' interpretations of disease. The solution to this is an objective system of classification that provides a comprehensive breakdown of the histopathological composition of any whole slide image. The solution to this problem is PHARAOH. Hello, I'm Dimitrios, and I have the great privilege of sharing with you today the research project I have been working on under the supervision of Dr. Diamandis. I'm excited to introduce you all to the Phenotypic Automated Reporting and Analysis of Histopathology, or as we like to call it, PHARAOH, the crowdsourcing platform and AI workflow which together will bring greater accuracy and efficiency to pathology. The process of developing a PHARAOH classifier begins at the cohort selection step, when the group of slides that will be used to train this particular classifier is chosen. Next, an image feature-based tile clustering tool separates each whole slide image into a mosaic of tiles clustered into color-coded regions based on their morphology. These color maps are shared with the pathologist who is elected to develop the classifier and can confidently annotate each color region with its true tissue label. Once the testing cohort has been annotated, it will include thousands of labeled tiles, many of which will share the same true tissue label and can be merged before being used to train the PHARAOH workflow's convolutional neural network, or CNN. Once the CNN has been trained to recognize the tissue labels on the training cohort slides, the completed classifier will be uploaded to the PHARAOH website. The newest member of the family of PHARAOH classifiers is the liver hepatocellular carcinoma classifier, which I developed in collaboration with Dr. Lidiane Marins, a pathologist in Brazil. This image shows one of the slides from the cohort used to train the classifier. Figure A shows the original hematoxylin and eosin, or H&E stained whole slide image, which, upon being run through PHARAOH, is overlaid with the color tile map in Figure B that distinguishes morphologically different regions by color. The distinctions drawn between regions are validated in Figure C, which shows the images generated by an AI nuclear segmentation tool of nuclei in 3 tiles taken from the regions of the color tile map labeled above each tile and circled in the color of the category they belong to in the histogram shown in Figure D. The universal application of the PHARAOH platform has allowed us to already host 6 unique classifiers, 2 of which are shown on the left side as they appear on the PHARAOH website, with the 11 novel classifiers on the right at different stages in the developmental pipeline. As our global library of classifiers grows, we come closer to reaching our goal of making PHARAOH the Wikipedia of histopathology. Since joining the PHARAOH team a few months ago as an undergraduate student with no AI or pathology expertise, I have expanded the network of PHARAOH collaborators by connecting with clinicians and researchers in UHN and other medical institutions around the world, while publishing 5 videos to the lab's neuroscience education YouTube channel, NeurosIQ. With PHARAOH, the possibilities are truly endless. Just take this slide as an example, which you may not have noticed had a pair of pathology monsters facing off against each other until you ask for some help from your new friend, PHARAOH.